Good afternoon, students. I am Professor Bankar DB, Department of Chemistry, RBNB College, Serampur. In previous lecture, we have learned the retrosynthesis of certain molecule like S-propanediol, epichlorohydrin, alanine and multistriatin. So, in this lecture, we will see the retrosynthesis of remaining two molecules, that is Pentanomycin and cyclamic acid. So in this lecture we will see the retrosynthesis of remaining two molecules. So we will start with first molecule, that is Pentanomycin. Here we consider target molecule as Pentanomycin. So this is structure of Pentanomycin. We have already learned the synthesis of Pentanomycin molecule using the concept of Chiron approach. Here we will see its retrosynthetic analysis. So in retrosynthesis we use disconnection approach and we will start from final product and end with the starting material. So this is one of the intermediate before final structure of Pentanomycin. Here we have C double bond CH2. So this structure can be converted into this structure. Here we have OTS containing intermediate. So the final precursor for the synthesis of Pentanomycin molecule is D-glucose. So we can, if we see the synthesis of this Pentanomycin, we start with D-glucose and that D-glucose undergo this type of different changes and finally it convert into Pentanomycin. But this is retrosynthesis. We start with Pentanomycin as a target molecule and we we end with D-glucose as a starting precursor. So these are some different intermediate which can be occurring during the retrosynthetic analysis of pentenomycin. Now we will see the retrosynthesis of succinic acid molecule. This is structure of succinic acid molecule. It consists of one double bond inside the 6-membered ring, one carboxylic acid and 3 hydroxyl group. So this cyanohydrin intermediate can be obtained from this ketonic compound, and this cyanohydrin intermediate can be converted into final succinic acid molecule. So this cyclic compound can be derived from this intermediate. Here we have different groups at this particular position. So final precursor for the synthesis of succinic acid is D-arabinose. So this D-arabinose can be converted into succinic acid by these different steps. Here we highlight some important steps during the retrosynthetic analysis and total synthesis of this succinic acid molecule by using the concept of Chiron approach we have already learned in our previous lecture. So remember, this D-arabinose act as a precursor for the synthesis of succinic acid. So we completed the retrosynthesis of given 6 molecule, as well as we have also seen the synthesis of that molecule using the concept of Chiron approach. So we have finished most of the syllabus of CHO 353, that is protection, deprotection and Chiron approach. Once again I will highlight the protection, deprotection groups we have seen in our previous lectures. as we know that protection and deprotection concept plays an important role in the organic synthesis. For hydroxyl protection, we have seen number of groups. Hydroxyl protection, that is OH protection. Here we have seen alkyl ether protection, alkyl ether protection. Then we have seen benzyl ether protection, that is here we seen OBN, here we can write down OR. Then we have seen acyl protection, that is here OAC. Then we have seen PMB protection, trityl protection, TMS protection, TBDMS protection. Then we have seen THP, MOM, MEM, and finally we have also seen a diol protection. In diol we have learned two molecules, that is acetone and cyclohexanone. So under hydroxyl group protection we have seen so many protecting groups. We have already learned its formation, that is protection and deprotection. So there are different conditions for the protection as well as for the deprotection. Second is amine protection. That is NH2 group protection. In amine we have seen benzyl protection, acyl protection, CBZ, BOC, and finally we have also seen FMOC protection. So all these protecting groups are very important in the viewpoint of organic synthesis, and some protecting groups are very important in the viewpoint of peptide synthesis. So this some CBZ, BOC, or we can say FMOC protecting group plays an important role in the synthesis of peptide. Then third functional group is carboxylic, that is COOH protection. So in our previous lectures we have seen carboxyl protection. First simple way is to form ester of the given carboxylic acid. So for ester we can use alcohol. Then second is DCCI, that is dicyclohexyl carbodiimide. This is also one of the important protecting group for the carboxylic group. Then we have learned DIP CDI protecting group for the carboxylic group, DIP diisopropyl carbodiimide. So this is also act as a coupling agent during the synthesis of peptide. Then fourth functional group is ketone and aldehyde. Ketone and aldehyde. In ketone and aldehyde we have seen glycol formation, then thioglycol formation, then ketal and acetal formation. So by these different ways we can protect the carbonyl group of aldehyde as well as carbonyl group of ketone. So these are some important protecting group for the aldehyde and ketone. In Chiron approach topic, we have seen the meaning of Chiron approach. So Chiron approach means to create the new molecule containing chiral center, and that molecules generated by the Chiron approach are synthetically as well as biologically active molecules. In that particular topic we have learned S-propanediol, then R and S epichlorohydrin, then L, that is plus alanine, then minus multi-striatin molecule, then Pentanomycin molecule, and lastly is succinic acid. So in Chiron approach topic we have learned synthesis as well as retrosynthesis of these 6 molecules. So we finish the Chiron approach topic and I will stop here. Thank you.